Welcome, ladies and gentlemen, to your MN11 notes where we're going to describe angle pair relationships. This is section 1.5 in your textbook. We have 5 key words here at the beginning of your note guide. These words are extremely important in geometry and in any upper level math class beyond geometry. The first is complementary angles. And really, to make it kind of simple, we're just going to say that the two angles, so you have two angles. So I'm going to draw a picture here to just describe what I'm saying. Let's say the angle is A and B. Well, if they're complementary, that angle A plus that angle B has to equal 90 degrees. So really, by definition, complementary angles really that the sum of two angles equals 90 degrees. That's complementary. Now, supplementary is the same idea, but the sum of the two angles equals 180 degrees. So instead of adding to 90 degrees, it adds up to 180 degrees. So I'm going to show that by drawing a straight line, which we know if we measure that, it'd be 180 degrees. And I'm going to say that this is angle A, this is angle B. So A plus B is equal, excuse me, to 180 degrees. So complementary is 90 degrees, the two angles add up to 90 degrees. Supplementary, they add up to 180 degrees. Two huge words. Adjacent, I'm going to write the definition of adjacent angles first. It's two angles that share a vertex and a side. So when you have adjacent angles, they have to share not only the vertex, and the vertex, like for instance up here in the supplementary angle one, the vertex is right here where the two angles share that vertex, and they share a side. In this case, they share this side right here. So an adjacent angle, an example of it would be if I draw a big angle and I break that angle up into two angles, not equal, just two angles. This one is neither supplementary or complementary. I just drew a random angle. Here, you notice these two angles, this angle here and this angle here, are adjacent because they share this vertex and they share this side. So adjacent angle. Here's an example of a non-adjacent angle that some people sometimes get confused. Like for instance, this right here. Now these angles, if you look at it, here you have an angle and here you have an angle. They are in fact sharing this side right here, but they are not sharing the vertex. There's a vertex here and a vertex here. So this is an example of a not non-adjacent, or I'm just going to say it's not adjacent. Okay, so adjacent shares a vertex and a side by definition. The linear pair, huge word, just so you know, linear pair. Linear pair is a set of adjacent angles, so they have to share a vertex and a side, but they are supplementary as well. So let me kind of explain that again. So a linear pair, so if it's adjacent and if it's supplementary, then it's a linear pair. So we start with this 180 degrees. That's the easiest way to say it. And here's the vertex. And kind of like my example, honestly, up here in supplementary angles, I drew a linear pair already. And again, by definition of a linear pair, you have to share a vertex, share a side, and the two angles, this angle plus this angle, has to add up to 180. So if I say this is angle 1 and this is angle 2, angle 1 plus angle 2 has to equal 180 degrees, and they're adjacent. So linear pair, by definitions of both. Now you might ask yourself, what's the difference between a supplementary angle then and a linear pair? Well, supplementary angle, I drew this example up here as a linear pair, but really what I could have done instead is I could have said, you know what, this angle right here, let's call it angle A, is, let's say, 80 degrees, and this angle right here, which is angle B, and let's say this here is 100 degrees. Obviously, these are not adjacent angles, but these two angles do add up to 180 degrees. So to be supplements of each other, they do not need to be adjacent. They just need to add up to 180 degrees. But linear pair, they need to be adjacent and also be supplement. So linear pair looks just like the diagram that I drew right there. Now, vertical angles, this is kind of an interesting concept. Vertical angles, the easiest way I can describe it is to really just create two lines that are crossing each other. And where they cross each other, they create these things called vertical angles. So let me just kind of say this. If this is A, this is B, this is C, this is D. So I'm not interested in knowing the actual angle measures. But a vertical angle are directly across from each other if you have this kind of situation. So for instance, angle A, and angle C are vertical angles, and also angle B is vertical to angle D. Now if you look at them very close, and this is something we're going to prove later on, but you are going to see that angle B and D actually are congruent and A and C are congruent. So vertical angles actually will be congruent to each other, while linear pair angles add up to 180 degrees. By the way, speaking of linear pairs, if you look at this, let me just kind of write this down as an extension from the above definition. If you're looking at linear pairs, we have A and B is a set of linear pairs, angle A and B, and also C and D. And you can go all the way around it. You can say A and D for linear pair, and also, I'm missing one of them, B and C. So anything that shares a vertex and a side and adds up to 180 and creates a straight angle is a linear pair. Vertical angles, on the other hand, are directly across from each other, and they will they will be equal to each other. Example number one, let's kind of use some of these definitions to understand or use them in geometry. It says, if angle 1 and angle 2 are complementary angles and angle 1 is 68 degrees, find angle 2. Now, if you can see and understand how to do it instantly, that's great. But really, a lot of times these get confusing for students because they're really struggling with understanding what it's looking like. So I'm just going to say, make sure you draw a picture. That helps a lot. So the first thing we underline here is that it's a complementary angle. So I'm going to actually, I know that complementary angles add up to 90 degrees, so I'm going to create a 90-degree angle. And I'm not going to really think too much about where I draw this adjacent ray. And I'm going to say that this is angle 1 and this is angle 2. Now, this is not a drawing to scale or anything like that. This is just to help me stay organized. Now, over here, it says angle 1 is 68 degrees. So I know this is 68 degrees. Well, then angle 2 is going to be the other part of the 90 degrees. So we're going to remember this is angle 1 plus angle 2 equals 90 degrees. Well, if you know angle 1 is 68 degrees and you want to know what angle 2 is, really essentially all you're going to be doing is saying 90 minus 68 degrees. And that is going to give us our angle 2, which is 22 degrees. And algebraically speaking, notice we did set up an equation right here. You could just subtract 68 from both sides and you end up with your angle 2. So again, you could just do it by number sense, or you can set up an equation and use your linear algebra to solve this. But essentially you need to make sure angle 1 and angle 2 add up to 90 degrees for that situation to be true. So our angle 2 is 22 degrees because 68 plus 22 is 90. So same kind of thing here with the supplementary angle. So here, example 2, we're talking about supplementary angles, which means that they add up to 180 degrees. To make it easy, I'm going to create um, a linear pair drawing. And I'm noticing they're saying 3 and 4, angle 3 and 4. I'm going to say this is my angle 3, this is my angle 4. I do know they add up to 180. Now, the measure of angle 4 is 56 degrees. So now we need to find our angle 3. So again, remember, angle 3 plus angle 4 is 180 degrees. And if we know that angle 4 is 56 degrees, we can just solve this by subtracting 56 from both sides and go 180 minus 56 degrees. So that means that angle 3, if I do this calculation really quick, is 124 degrees. So let me just put this angle 3 over here again so that you can see. Okay. And again, after a while, you won't need to do the picture, but I'm just making sure that you realize the picture does help, especially if you're starting to get confused with which ones complement, which ones supplement. Example 3. If angle ABC and CBD are linear pair, is a linear pair, and ABC is equal to that expression, and measure of angle CBD is equal to that expression, 4x plus 8, find the measures of each angle. So the first thing I always do is after I read it usually again to myself, and then I really underline what I'm trying to find, which is find that measure of each angle. I also pick key words here. I see linear pair. Linear pair, I know for a picture, looks like this. And I'm just creating a linear pair. And I'm going to put 3 points. Right here, right here, right here, right here. Or it's 4 points, I suppose. And I'm going to first realize that there's an angle ABC. So I'm going to write A, B, C. And I also know there's an angle CBD. CBD. And remember, the B is your vertex. This, always the middle letter in your angle, is going to be your vertex. Okay, so looking at that, I know that angle ABC, according to this up here, right here, is x plus 2. So I'm going to put x plus 2, and that's representing the degrees in there, right here. And then on this other side, CBD is 4x plus 8 degrees. Now, we know, again, that a linear pair adds up to 180 degrees. So if that's the case, we know that angle ABC plus the measure of angle CBD should add up to 180 degrees. A linear pair is supplement. They're supplements of each other. Now, ABC is represented by x plus 2 plus CBD, which is represented for x plus 8. And those two should equal 180 degrees. So now we're going to solve this and find out our unknown, our x value. Now that's not a degree, that's our unknown, our variable, and that's what we're solving for first before we can find our angle. Now notice I had my parentheses just keep it organized. There's no distribution or such, so I'm just dropping those parentheses. I have x, I have 4x, that means I have 5x. I have 2, I have 8, that means I have 10, equals 180. I solve for x, so I have 5x equals 170. I divide by 5 here, and I end up with an x value of, let me see, it's going to be 3, 3, 4. So my x, my unknown, is 34. Now that's, I shouldn't have even, you know what? I shouldn't have squared that because that's really not our answer, is it? That's our, I mean, it's highly helpful. So instead what I'm going to do is I'm going to underline it to make sure I realize that's an important thing there. So now let's find our angle measure of A, B, C. So all we did, again, to take a step back, is the linear pair we know adds up to 180 degrees. That's why we can add these two angles to 180 degrees. We substitute our expressions in for those angles. We solve for x. That gives us 34. Now, since we know that ABC is represented by x plus 2, we can then just put that 34 in for x And we know then that ABC is 30. Oops, my hand is faster than my, okay, 36 degrees. There we go. So the measure of ABC is 36 degrees. That I'm going to circle. Now to find the measure of CBD, you can do one of two things. You can just take 180 minus 36, and that'll give you your CBD angle. But you always want to make sure you didn't make a simple mistake. So I'm going to actually calculate it out just really quick and make sure that it's all adding up properly. So angle CBD, if I put this 34 in for X, 4 times 34, and then I add the 8 to it, I'm going to end up with 144 degrees. And that is a great answer to see, because then I can check my answer really quick. 36 plus the 144 is 180, so that is following the linear pair definition. So I just found my two angle measures. So kind of working backwards and checking your work there. Okay, so you're going to have a chance to practice this skill in your homework, and you can ask any questions in class. Thanks for tuning in.